Hello everyone, my name is Pooja. I am the trainer for blockchain from Uplatz, and today's topic for the practical is blockchain-based land registry system. Okay, so first I'll just write down the topic name, that is blockchain-based land registry system. Okay, so we'll start with the code. Like as always, first here we'll search for anaconda. Anaconda. Yeah, here we get. Then just open it. It will take some time. Just wait for some seconds. Yeah, there's an instance. Okay. So it's saying that it's already running. Here we get it. Then click on launch. Okay. So here it would be extracting. Launching the notebook. See, here it's showing. Okay. Just wait for a few seconds. And you'll just view, and here you will open Jupyter app because it is the I'm sorry, I'm sorry. It is the place there you need to work on. Okay. Then here in the notebook and Python Conda, you just click the notebook one. You can see we have got the page over here. Just extend it. Okay. So now we'll start with the code. Is basically talks about the land registry. So first we would import hashlib, comma, time, comma, JSON. Okay. Then here it talks about we put a command, and the command is of transaction class for land or for property transfers. Okay. Then we'll start with class land transaction. Then you would just define init then there is self, comma, property underscore ID, comma, seller, comma, buyer, comma. These are the attributes that we are working on. Area, comma, location, As this is for land registry, these are the required areas that we'll be working on, comma, price. Yeah. Then we'll just define each one of it. That is self dot property underscore ID, which is equal to property underscore ID. Then self dot seller property we have done, property ID, and self dot seller, which is equals to seller, then self dot buyer, which equals to buyer, then it is self dot area, which equals to area. Okay, then we'll just add a command over here, a comment basically, that says n square feet. Then there is self dot location, which equals to location, then self dot price, which equals to price, and we'll be looking for self dot timestamp equals to time dot c time. Okay, then you would just define okay. We can define and represent so here we are looking for just a second. Okay, yeah, now it's proper. Represent self. Okay. Then you would just return JSON dot dumps. This self dot dictionary underscore comma indent equals to 2. Okay. Then we'll pass a comment which says block class to just store the transactions. Okay. Then it is class land block then you would just define init, then self, comma, index, comma, transactions, comma, previous underscore hash, comma, nonce equals to 0. Okay. Then here it is self dot index, which equals to index, then self dot timestamp, which equals to time dot c time, that is self dot transactions, which is equal to transactions when it is self dot previous hash, which equals to previous underscore hash, self dot nonce, which equals to nonce, then it is self dot hash, which equals to self dot compute underscore hash. So after this, we would just define it. So define compute underscore hash, and then we will write down self. Then you would just block underscore data, which equals to index, then self dot index, then there is timestamp equals to self dot timestamp, comma. So this is the one step that we have seen so far, right? That we have to compute the hash, the block data, timestamp. Okay. Now we'll see more to it. So let's go to the second part. Now we have done with timestamp. We need to write transactions. For transactions, here it would be dot underscore dictionary for transaction in self dot transaction. Okay. Then we would write down previous underscore hash. Okay. So in previous underscore hash, it would just be self dot previous underscore hash. Okay. Then in inverted commas, we write nonce and it is self dot nonce. Okay. And the block data line first we'll just match like the same line. Okay. So below that only block data should come. Block underscore string JSON dot dumps. Then here it is block underscore the data comma sort underscore the keys over here. Okay. Then keys equals to true. Then you would just return the hash lib dot SHA-256 block underscore string encode. Then this bracket will also be closed. Dot okay. X digest. This one will also be closed. So I'll just check. Here the brackets are closed. Here you would open two and then close. And here you would open and then close. So brackets are closed. Then we'll now look for blockchain class to just manage the ledger. Okay. Then it will be class land registry chain. Okay. So in the class it is land registry chain. Then the difficulty level here is equals to 3. Then you would just define init, then self self dot chain self dot chain equals to self dot unconfirmed underscore the transactions. Then you would just self dot create underscore genesis underscore block. Okay. Then here this part is done basically to identify self and then the difficulty level and everything. Then we'll move to another part. Again, we'll define. So define create underscore genesis underscore block self then it is genesis equals to land block comma 0 then self dot chain dot append. Then here you would just write as genesis. Then define the last underscore block and this you will write down self then return self dot chain then you would define add transaction self comma transaction. Okay, then we'll write down self dot divided by 300 becomes done. Okay, then self dot unconfirmed transaction dot append, then the transaction. Define proof of work, that is self, comma, block, then block dot nonce equals to 0. Okay. So we have so far seen block dot nonce equals to 0. Okay. Then here we would just compute those values. So computed underscore hash equals to block dot compute underscore hash. While not computed hash dot the starts with 0, self dot difficulty block dot nonce one computed underscore hash, which equals to block dot compute underscore hash. Then this command you will return while loop we have done. Then you will just return the command. So you would return it as computed underscore hash. Okay. Then you would define it again. So define add underscore the block. For this over here it is so comma block comma root. Then if loop block dot previous underscore hash. Okay, equals to self dot last. There would be space over here. Underscore the block dot hash. Okay, then this command would just return as false. And if not true, dot starts with here it would be 0, self dot difficulty and here again return it as false. Okay, then we have block. Okay, dot hash which equals to proof that it is self dot chain dot append block. Okay, then just return it as true. Okay, so this much we have to see. Now we'll move forward. Then again we'll define. So now we would define mine here it is self. So if not self dot unconfirmed underscore transactions so define mine and self. We have defined it, then it's not self that dot unconfirmed. Then the transactions. So you would just return it as the false. Then last underscore block equals to self dot last block, then it is new underscore block, then land block, then you would just open the curly bracket and that index equals to last underscore block dot index, and then here you would denote as plus one, then comma. Okay. After plus one, there would be transaction equals to self dot unconfirmed underscore transactions. Here that would be previous underscore hash equals to last underscore block dot hash. Okay. Then here it is proof equals to self dot proof of work. Then here it would be new underscore block, then self dot add underscore block new underscore block proof. Then self dot unconfirmed underscore transaction equal to, then we'll open and close the square brackets. Then this will return as return the new underscore the block. Okay. So we have completed proof of work and everything. Now here you need to create one. So Here you would just create instance of the blockchain, which would be land underscore chain, which equals to land registry chain. Okay. Just scroll a bit up. Okay. Now here we'll pass another comment which says that add land or as well as property transactions. Okay. So this is T1, which equals to land, as we are looking for land registry. So land transaction. So in here, property, so prop 001, comma, then here it would be John D. Mhm. Okay. Then after this, start with Alice Smith. Yeah. Then 1200 Mumbai. So here it would be 9500000. Okay. Then T2 equals to land transaction. So here we'll write as property 002. It would be here Mike Rana. Okay. Then it would be Rahul Kapoor. Okay. So here we'll number it as 800, comma. The location would be Pune, which is 670. Okay. Then land underscore the chain dot add underscore transaction T1. Okay. And then it is land underscore transaction dot add underscore transaction, which is T2. Okay. Then here we need to mine it. So we pass one comment of mine block, that is mine underscore block equal to land underscore chain dot mine. Okay. Then here it is show mind block and its transactions. For that, first you would just print F quote commas. Here it would be as block, then we'll pass a comment again. And here it would be mine mind underscore block dot index mind. Okay. Mind with hash, which over here is mind underscore block underscore hash. Okay, this is done. Then for the transaction in mind underscore block dot transactions, you would just print the transaction. Okay. So printing the transaction here. Now you would just show the functionality of it. So function to get history of a particular property. Okay. So that would be defined get underscore the property underscore the history and then in here you would define as property for the ID. Then just print F where there would be ownership history for property ID, then property underscore ID, then for block and land okay. So for that for block and land underscore the chain dot chain for transaction and block dot transaction if transaction dot property underscore the ID. So this would equal to property underscore ID. Then you need to print it to print this function. So you'll open the curly braces and in that you will write down transaction dot the time stamp, then transaction dot the seller. So this here would be transaction dot buyer. Okay. So then here there would be example usage. Okay. And for that would be get underscore the property underscore the history for property one. Prop 001. For that, we need to get the history. Now let's just see. Okay, so here just in the error, like we'll see what are the errors are. Okay, so here is the output as you can see. So block one, that is mined with hash. Okay, so here you can see the block one is mined with hash. So the digit that we are getting it's shown. Then the property ID, we have denoted it as prop 001. And the seller was for that was, I'll show you up. Okay, so property one. Okay. So sellers are here. You can see John D. Alice Smith, correct? So the seller was John D. And you can check over here. The buyer was Alice Smith, because we have put the command before like the seller and the buyer. So it is giving result in that manner only, correct? So you can see the result. See, in this we have first kept seller and then we have defined buyer. So in this case, that is what I was showing you. It's the same. First the seller, that is here you can see John D. And the buyer is your second one. So here Alice Smith is your buyer. So seller and buyer both you can see. Then area is 1200. Like why we have using this particular we can say attributes, because here it is self, then the property ID, that is we are searching for property one. And then we have asked for seller, I've asked for buyer, and the area, the location, and the price. So these are the attributes, correct? That seller, property ID, self, property ID, seller, buyer, ad, area, location, price. So we need to fit in the output that we'll get now. It should be fit in such a way that these are the areas or these are the attributes that we are receiving it, because that is the prompt or that is the command that we have inserted. That is the thing that we have defined. So definitely our output is correct. That's the reason we are getting in such a way. See here, property ID, seller, buyer, area, location, price, timestamp. In the correct manner, we are getting it. Okay. So for property ID here, it is property for 001 is the ID. And then seller is John D, buyer is Alice Smith. Area square feet is 1200, and the location where it is located is in Mumbai basically. And the price also we have seen above, that was this amount. Okay, 95 lakh basically. Okay, it's 95 lakh. And then the timestamp is Sunday. The timing is July. Like current timing it's showing at the time I have we have received this output. Same for property 2. We have got property 2 ID number. Seller is Mike Rana, buyer is Rahul Kapoor. Area is 800 square feet, wherein it is in Pune, located in Pune, and it is 67 lakh. Okay, and the timestamp is the current timestamp which was showing 4 minutes before. So the ownership history for property ID, the prop 001 and Sunday, July, John D. Ellis Smith, because here example usages of property 1. Correct? So we have got the output, we have got the result, and this is it. So that's all about today's session. Thank you.